Okay, today we study David Ricardo's law of comparative advantage, that is the grounds for supporting international trade and specialization. And I want to start with a daily life example, which doesn't seem to have anything to do with international trade at the first glance, but you'll see the connection before long, so you have to be a little patient. The following is the example. There are two persons, Mr. Quick and Mr. Slow, and each has 10 hours a day to work. There are two kinds of jobs. A. Cooking dishes. B. Washing dishes. Their productivity is given by the following productivity table. For example, if Mr. Quick spends 1 hour on cooking, he can serve 10 customers. He can cook dishes for 10 customers. Or, alternatively, if he spends 1 hour on washing, then he can serve 30 customers. He can wash dishes for 30 customers. On the other hand, if Mr. Slow spends 1 hour on cooking, he can serve 2 customers. If he spends 1 hour on washing, he can serve 18 customers. Note that Mr. Quick is more productive than Mr. Slow in both types of jobs. He's better at both cooking and washing. Here is a question. If they work separately, if Mr. Quick and Mr. Slow work separately, how many customers can each of them serve? Here, let's assume that in order to serve one customer, both cooking and washing are necessary. I repeat the same table from the previous slide, and this is the only information you need to answer this question. Let us start with the problem of Mr. Quick. How many hours should he spend on cooking and washing to maximize the number of customers he can serve? To answer that question, let's denote by HC the number of hours he spent on cooking and by HW the number of hours he spends on washing. Because both cooking and washing are necessary to serve one customer, the number of dishes he cooks and the number of dishes he washes should be the same. And that's what the first equation means. He can cook 10 dishes per hour, so if he spends HC hours on cooking, the total number of dishes he cooks is 10 times HC. He can wash 30 dishes per hour, so if he spends HW hours on washing, 30 times HW is the total number of dishes he washes, and they should be equal. The second equation simply means that he works 10 hours in total. So the number of hours he spends on cooking and the number of hours he spends on washing should sum up to 10. If you solve this system of equations, the solution is HC equals 7.5 and HW equals 2.5. If you plug HC equals 7.5 back into the left-hand side of the first equation, or alternatively, if you plug HW equal 2.5 into the right-hand side of the first equation, you can see that Mr. Quick serves 75 customers. Okay? Out of 10 hours he has, he allocates 7.5 hours on cooking and 2.5 hours on washing, and that way he can serve the maximum of 75 customers. The problem is almost the same for Mr. Slow. He can cook 2 dishes per hour and he can wash 18 dishes per hour. So if he spends HC hours for cooking, he can serve cooking for 2 times HC customers. If he spends HW hours on washing, then he can serve washing for 18 times HW customers. These numbers should be the same. The number of dishes he cooks and the number of dishes he washes should be equal because each customer needs both cooking and washing. Mr. Slow also has 10 hours in total. You have the same kind of system of equations. If you solve it, you get the solution. Mr. Slow spends 9 hours on cooking and 1 hour on washing, and that way he can serve 18 customers, and that's the maximum number of customers he can serve by himself. Yeah? You substitute this 9 to this 2HC and you get 18. So Mr. Quick can serve 75 customers while Mr. Slow can serve 18 customers. So by working separately, they can serve 75 plus 18 equal 93 customers. Now suppose their restaurants are next to each other, so they don't have to work separately. They can collaborate if they want to. Now suppose Mr. Quick spends all his time on cooking only. He can cook 10 dishes per hour, so if he spends all his 10 hours on cooking, he can cook 10 times 10 equal 100 dishes. So the following is the idea. Mr. Quick says to Mr. Slow, "Okay, Mr. Slow, let's collaborate. I'm good at cooking, so I'll cook as much as possible." Now what is Mr. Slow's problem? The second equation is the same. He has 10 hours in total, so the number of hours he spends on cooking and the number of hours he spends on washing, the sum should be 10. The number of dishes cooked and the number of dishes washed should be equal, but given that Mr. Quick cooks 100 dishes, now the number of dishes Mr. Slow cooks plus 100 should be equal to the number of dishes Mr. Slow washes. So we have plus 100 here. If we solve this system of equations, HC equals 4 and HW equals 6. So Mr. Slow spends 4 hours on cooking. Cooking 2 times 4 equals 8 dishes. Because Mr. Quick also cooks 100 dishes. That's 108 dishes cooked in total. And Mr. Slow also spends 6 hours on dishwashing. And that way he washes 18 times 6 equals 108 dishes. So, they are now serving for 108 customers. Do you remember how many customers they were serving by working separately? By working separately, they were serving for 93 customers in total. Now, by working together, they are serving 108 customers. That's 15 customers more. Note that when they work together, Mr. Quick is specializing in cooking, and consequently, Mr. Slow is spending more time on dishwashing than before. You know, if Mr. Quick is better at cooking than Mr. Slow, and Mr. Slow is better at washing than Mr. Quick, if they have different strengths, then of course, cooperation should lead to larger production. But this example is a little surprising because cooperation and specialization lead to larger production despite the fact that Mr. Quick is better at both types of jobs than Mr. Slow. In other words, Mr. Quick has absolute advantage over Mr. Slow both in cooking and in washing. And yet, cooperation and specialization lead to more production. And this phenomena was first formulated by David Ricardo. Now I want to explain David Ricardo's law of comparative advantage. So let me first explain what comparative advantage is. For each person, let us compute the opportunity cost of cooking in terms of washing. For Mr. Quick, the opportunity cost of cooking in terms of washing is 30 over 10 equal 3. Remember, in 1 hour, Mr. Quick can cook 10 dishes, or he can wash 30 dishes, which means that every time he cooks 1 dish, he has to give up washing 3 dishes. Let me repeat again. Every time Mr. Quick cooks 1 dish, he has to give up washing 3 dishes. And in that very sense, his opportunity cost of cooking in terms of washing is 3 dishes. Because in order to cook 1 dish, he has to give up washing 3 dishes. For Mr. Slow, the opportunity cost of cooking in terms of washing is 18 over 2 equal 9 dishes. Because for each dish he cooks, he has to give up washing 9 dishes. So if you measure the cost of cooking by the foregone amount of dishwashing, cooking cost is much higher for Mr. Slow. This opportunity cost is something personal. So if you consider opportunity cost of dishwashing in terms of cooking, then everything will be the other way around. For Mr. Quick, the opportunity cost of dishwashing will be 10 over 30 equal 1 over 3. That's inverse of 3. For Mr. Slow, the opportunity cost of dishwashing in terms of cooking will be 2 over 18 equal 1 over 9. So the opportunity cost of dishwashing is higher for Mr. Quick. Okay, this opportunity cost is something very personal because we are measuring someone's cost of doing something in terms of the amount of the other work he has to give up. The story will be completely identical even if we have country X and country Y rather than Mr. Quick and Mr. Slow. And instead of cooking and washing, let's say we have agricultural products and manufactured products. Let's say both countries have 1 million population and each person can work 10 hours a day. So that means that country X has 10 million hours, country Y has 10 million hours. These numbers are completely the same as in Mr. Quick and Mr. Slow's example. So we still have the fact that country X has comparative advantage at producing A. Now that we understand opportunity cost, we can define comparative advantage. Suppose there are two agents, X and Y. They can be persons, companies, countries, whatever. In our example, it's Mr. Quick and Mr. Slow. Suppose also that there are two kinds of production, A and B. In our example, it's cooking and washing. Mr. X, for country X, is said to have comparative advantage at producing A if X's opportunity cost of producing A in terms of foregone amount of producing B is smaller than that of Mr. Y or country Y. It's a very complicated concept. It's conceptually difficult, but mathematically it is easy. In our example, the opportunity cost of cooking in terms of washing is smaller for Mr. Quick. And as we saw before, the opportunity cost of dishwashing in terms of cooking is smaller for Mr. Slow. It's 1/3 and 1/9. So it's smaller for Mr. Slow. So according to this definition, Mr. Quick has comparative advantage at cooking and Mr. Slow has comparative advantage at washing. Okay? And actually it is a general fact that if person X or country X has comparative advantage at producing A, then person Y or country Y has comparative advantage at producing B. It's impossible that X has comparative advantage at both A and B. Okay, we are ready to state Ricardo's law of comparative advantage. Two countries can gain from trade or specialization by putting more focus on the production for which they have comparative advantage. That is, both countries can gain from trade. In economics term, that's Pareto improvement. And this is even true when country X is better at producing A and at producing B than country Y. Recall the story of Mr. Quick and Mr. Slow. Mr. Quick was better than Mr. Slow, both at washing and cooking, and yet cooperation and specialization led to more production. Same thing can be said about countries. Imagine two countries, a developed country like United States and some developing country. The US is better than the other country both in agriculture and in manufacturing. Let's say the United States has comparative advantage in manufacturing. In that case, the other country, the developing country, has comparative advantage in agriculture. If the US shifts their resources to manufacturing and the other country, the developing country, shifts their resources to agriculture, and then they trade, they can enjoy more production and more consumption. That's what Ricardo's law says. Okay? So Ricardo's law is a strong support for free trade argument. Of course, the reality is not that simple, so let's look at a couple of exceptions before we conclude this class. For example, there is a situation in which one country is still at an infant stage for producing some goods. They may be potentially good, but they are still a baby. Imagine such a situation. Like a Mr. Quick is an experienced old man and Mr. Slow is a 14-year-old boy who doesn't know anything about cooking or washing. Or, X is USA and Y is Japan in 1950, which doesn't know much about producing automobiles. You know, Specializing in production with comparative advantage may destroy their potentials. So it makes sense in the long run to protect developing countries' manufacturing because they may be good in the future. Exception 2. Suppose country X is very good at producing A, but it is done by a monopolist, some monopolistic company. For in that case, if country Y gives up producing A and imports A entirely from X, then country Y will also suffer from monopolistic price. So it may make sense for country Y to try to protect their own production of A. Exception 3. Too much concentration may lead to vulnerability to risk of environmental change. Country X specializes in production A and country Y specializes in production B. Well, in that case, what happens if country X is hit by natural disaster, for example, or country X gets involved in war? And the import of product A from country X to country Y simply stops. Now country Y is in trouble. Yeah? So it may make sense for country Y to try to protect their own industry to avoid this kind of risk from too much concentration. The Ricardo's model is a very simple model. So in order to discuss these issues such as technological development or monopoly or risk diversification, one should develop a more complex model. But still, Ricardo's model is a very good starting point to discuss international trades.